Hello. We're now going to talk about quartiles. So this is the last topic in section 3.3. Quartiles divide a data set into four groups. Theoretical model would be that when you have your data set, you can arrange your data set so that the lowest value is first. Any value that falls in the next interval of 25% will be said to be in the first quartile, which is denoted as Q sub 1. If you measure off another 25% and construct an interval, any value falling in there will be in the second quartile, which is denoted as Q sub 2. And we can repeat this process until we get to the highest value. Okay, to determine the quartiles, it's a very simple process. Obviously, the first step is we put the values in numerical order. Second, we determine quartile 2. It is the median of the entire data set. Next, we determine quartile 1. It is the median of the values that precede quartile 2. Finally, we determine quartile 3. It is the median of the values that follow quartile 2. And then we like to measure the middle 50% of the data set. This is known as the interquartile range. And you just find the difference between quartile 3 and quartile 1. And that's our formula for IQR. Okay, so let's take a look at an example just to sort of understand this process. Let's assume that we're given the following data values. Obviously, the first step is we put the data values in numerical order. Then we find the median of the entire data set, and the median is 11. Thus, we know what quartile 2 is 11. Remember, quartile 2 is the data value that's equal to the median of the entire data set. Next, we focus on those values that precede 11. And those values would be, in this example, 4, 6, 7, and 8. We're going to use these values to find quartile 1. So we just take the median of these four values. And the median is found by taking, since there's an even number of values, we add the two middle values together, 6 and 7, and divide by 2. Thus, quartile 1 is 6.5. And now we write down the last four values, the four values that follow 11, and we find the median of these four values. Once again, since there's an even number of values, you take the midpoint of the two middle values. So we add 14 and 18 together, divide by 2, we get 16. Finally, we will compute IQR. IQR is just the difference between Q3 and Q1. So 16 minus 6.5 is 9.5. And thus we have our three key values. Q2 is 11, Q1 is 6.5, Q3 is 16, and IQR is 9.5. At this moment, you can pause the video and work out the two examples on page 7. We'll continue with the next part of quartiles. The next part deals with what are called outliers. An outlier is an extremely large or extremely small value that will distort the data set. So we want to recognize these outliers and then typically eliminate them from the data set. To do this, we use what are called fences. They're theoretical constructs that are computed using the following formulas. The left fence will be Q sub 1 minus 1.5 times IQR, and any data value that falls to the left of this left fence is an outlier. The right fence is Q sub 3 plus 1.5 times IQR. Any value that falls to the right of the right fence is an outlier. values between the two fences are your regular data values. So let's take a look at our next example. We have a set of data values. First step, we put them in order. Right away we can kind of recognize that 120 looks like it doesn't belong to this data set. So that potentially may be the outlier. We used our techniques that we previously learned. We learned that, and you could just kind of test this out, but Q sub 1 is 5.5, Q sub 2 is 22, and Q sub 3 is 28. We compute IQR, we take Q3 minus Q1, so 28 minus 5.5 is 22.5. And now we calculate our left fence just by inserting these values into the formula, and we end up with negative 28.25. We compute the right fence using our formula, and we end up with 61.75. What I like to do is plot the fences, and I'll plot them in red alongside the data set, so then we can compare to see which values are to the left of the left fence and which values are to the right of the right fence. So if you notice, the left fence is at the extreme left. There's no values that precede it, thus there's no outlier that's on the left side of the data set. However, as we suspected, 120 is to the right of 61.75, which is our right fence. Thus 120 is the outlier for this data set. And so for just to kind of run through the process, you compute the two fences, and then you search for values that are to the left of the left fence or to the right of the right fence. Those values are known as outliers. So I have an example for you to try. You can pause the video and try example 5. And then later on you can check to see if you have the answers correct. Let's go on to our next topic. Our next topic deals with graphing quartiles. And to graph quartiles, we construct what's called a box and whisker plot. Okay. So just to kind of go through the process, we're still going to put all the numbers in numerical order. We're going to find all three quartiles, Q sub 1, Q sub 2, Q sub 3. And we also want to recognize what's the lowest and largest value. Now to draw the box and whisker plot, what we need to do is we need to use the quartiles to draw the sides of our box. And then the lowest and highest values, we're going to extend what are called whiskers. They're basically lines. The whisker on the left side will extend to the lowest value. The whisker on the right side will extend to the largest value. So let's take a look at an example. Let's say we're given the following data set. Once again, we're going to put the data set in order, numerical order. That's our first step. Then we determine the median, which is going to give us Q sub 2. So the median of 11 and 15, add them together, divide by 2, you get 13, because we do have an even number of data values. So our median is equal to Q2. And then we focus on the values that precede it, 9, 10, and 11. The median of 9, 10, and 11 is 10, so Q1 is 10. And then we look at the values that follow our median, 15, 23, and 38, which are right here. 23 would be the median of that data set, or that portion of our data set. So we know that Q2 is 13, Q1 is 10, Q3 is 23. The smallest value in our data set is 9, and the largest is 38. So now when we draw this box plot, the edges, this edge will correspond to Q1. So Q1 is 10. This edge will correspond to Q2, which is 13. This edge will correspond to Q3, which is 23. And then around these edges we draw the box. So remember, each edge, Q1, Q2, Q3, and you construct the box around those edges. Then we draw the whiskers. So the first whisker will extend to the lowest value. The lowest value is 9, so on the left side the whisker is going to be somewhat short. Whereas on the right side, our highest value is 38. So from 23 we draw a line all the way to 38. We extend it off to 38. And so now we have our box and whisker plot, and then we can use it to analyze the data. You can see each portion of this graph represents the quartile. So this whisker represents the first 25%. This portion of the box is the next 25%. This portion is the third 25%, and this last portion represents the last 25%. And we can just see that the data values are somewhat skewed to the right. They're stretched out to the right, which typically indicates that there may be an outlier which you can search for. But this is how we construct the box plot. You need Q sub 1, Q sub 2, Q sub 3, the lowest and the highest values. And so we have 2 examples for you to try. And once you complete these examples, you'll be done with this packet. Hold on to the packet, and I will collect the packet once we resume classes.